Good afternoon and welcome to NASA's Johnson Space Center, where we are busily getting ready for 3 upcoming spacewalks, the first of which will kick off on Thursday this week. Here to tell you about everything that the crew on board the International Space Station is getting ready to do and what they'll be doing on those spacewalks, we've got a great panel of experts lined up for you. First, here to my left is Kenny Todd, the Operations and Integration Manager for the International Space Station. Down the line, we have Judd Freeling, Space Station Flight Director, who will be overseeing a couple of the spacewalks. Then next to him, Tim Braithwaite, the International Space Station Program Liaison for the Canadian Space Agency. And then finally, our 2 spacewalk officers who will be in mission control. First, Jacqueline Kagi, who will be the spacewalk officer for the first spacewalk, and Glenda Brown, who will be in mission control for the second and third excursions. We're going to start off with an overview from each of these folks, and then we'll take questions both here in the room and on social media. If you're watching that way, you can send in your questions using the hashtag AskNASA. Kenny?
Thanks, Brandy. Good afternoon, everyone, and it's great to see you and great to be here. We'll talk a little bit about the EVAs today, but when talking about some of the things going on around these EVAs, I figured I'd kind of give you an update on what's going on board. Crew's been pretty busy the month of September. As most of you know, we brought home Peggy Whitson and Jack Fisher and Fyodor your chicken back in early September. Around middle of September, we were able to welcome a new crew on board, Alexander Masurkin, and also Joe Acaba and Mark Vandehei. It was great to get the USOS crew up to 4, where we'll be for some time going forward. And so anyway, the crew's been busy this last couple of weeks, primarily trying to get completed with the SpaceX 12 mission and get that cargo safely back to the ground. Happy to report that everything was nominal in that regard. All the science returned home safely and has been delivered to a bunch of principal investigators who are extremely happy with the results. This week, part of last week and this week has been dedicated mostly to trying to get ready for these EVAs. As you can imagine, there's a lot of work that goes into doing the preps for these EVAs. The folks to my left will be talking to you obviously about some of the more detailed parts of getting ready to do the EVA. But our 4 USOS crew, Randy Bresnik, Paolo Naspali, representing Ozzy, and Joe Acaba and Mark Vandehei have been doing a fantastic job taking care of the USOS, and Sergei Brzezinski and Alexander Masurkin, again, doing a very nice job on the Russian segment. So overall, the station's in very good shape. When we look forward to the next 3 months, taking us out through the end of the year, as I said, the EVA is coming up the next 2 to 3 weeks here. We're going to plan to do EVAs on the 5th of October, the 10th of October, and again on the 18th. We also have some robotics activities going to be doing in and around that time frame once we get the SSRMS back up to its full and recovered capability. In addition, we've got our usual suspects when it comes to science. We're doing a lot of human research. We've got some protein crystal growth going. We're growing some plants. We're doing some radiation experiments. So a lot of good science going on board in and around these EVAs. So there's, again, plenty to do here in October. Once we turn the corner into November, we're going to be looking hard and getting ready for the OA-8 mission, which is an orbital ATK CRS flight. Again, bringing about 3,200 kilograms worth of cargo. So we're always excited when we get a visiting vehicle on board. Lots of science. Usually get some goodies for the crew. It's just an all-around good thing when we get new vehicles on board. So anyway, that vehicle is going to launch on the 10th of November, berth on the 14th, and we'll probably try to turn that vehicle in around 3 weeks or so. So if everything works out right, we'll unload it, get it packed back up, and set it free probably around the first week of December. Along the end of the month, around the 28th of November, we're currently scheduled to see the SpaceX 14 launch, followed by berthing a couple of days after. So for a couple of weeks there, we'll be doing a dual berth cargo visiting vehicle configuration, which Typically, again, that presents challenges, but challenges we've dealt with before, and again, I don't see anything insurmountable there. So we just have to make sure we get all that work done. So don't see any challenges with that. When it comes to December, we're going to be trying to finish up the SpaceX 13 mission by the end of December, and about the middle of the month is when we're going to do a crew rotation. So that'll be something we'll deal with in the middle of December, when we'll see Randy and Paolo come home, and then a few days later we'll welcome the next crew aboard. So anyway, we'd be down very long. We'll only be down 3 or 4 days from the standpoint of a smaller crew, and we'll jump back up to 6 pretty quick in the middle of December. The first domino in this whole plan that's got to fall is this set of triple EVAs that we're here to talk about today. Our primary objective, if you look at the EVAs as a whole, is to make sure that we get the SSRMS recovered and fully functional. And as most of you know, the SSRMS played a critical role in the assembly of station, but I would tell you it's playing just as critical a role today in the overall execution of the program when it comes to science, when it comes to inspections, when it comes to putting visiting vehicles on station. It's just an absolute critical asset that our Canadian partners have contributed. So anyway, we're very excited about getting out and getting it fully recovered and functional. And our original plan going out for this EVA was actually to do a different end of the arm. We were going to go out and change out a different end of the arm. This was a concern that was brought to us a couple of months ago by our Canadian partners after looking at some imagery of one end of the arm, and they noticed what I'll call kind of more of a wear and tear type of concern, and they brought the recommendation that it would probably be good to change out the latching end effector to again make them more robust going forward. As a program, we all agreed to that, and we found a home for it in this set of triple EVAs that we're doing here. Subsequent to that, during a robotic operation on orbit, we had an issue with the other end of the arm, and that particular issue, once we looked at it a little bit closer, gave us more cause for concern going forward. And so we made the decision as a program here several weeks ago to just change the operation to say, instead of changing out the original lead, we'll go to the other end and change out the one that gives us more cause for concern, and the one that we originally were planning to change out, we'll change that out after the first of the year. Again, that's more of a wear and tear issue, and we have some runway to go do that. So we've got a couple EVAs we'll do in the January, February time frame, and we'll go swap out that particular lead. But first and foremost, we want to swap out the lead that again gives us the highest concern, the problem that popped its head up here a few weeks ago, and the team is ready to go do that. And so I don't anticipate any issues with that going forward into the EVA. That'll be our first EVA. As far as the rest of the things, I kind of put them in the cats and dogs sort of category. You're going to hear the guys and gals talk about changing out cameras. Those are cameras that have kind of given us problems over the last few years. But again, that's something that we need to go do, and it's a good opportunity to go do it, and we'll go get that work behind us. As far as the readiness to do the EVAs, suits are in good shape. We're not working anything from a program standpoint on the suits themselves. We think we got a couple of good, healthy suits, and we're ready to go. Crew and Judd and the team will talk to you about that. The crew's been working for a while now, leaning in this direction with their studies and procedure reviews and working with the ground and all that. On Wednesday, we'll do a mission management team meeting, and barring any late breaking issues, I anticipate will be a unanimous go. So everything looking real good to this point, and I'll toss it to Judd and let him talk to you about the specifics of the EVA.
Thanks, Kenny. I'm Judd Freeling. I'm the lead flight director for the second two spacewalks in this series. The first spacewalk will be led by Tony Sacacci. And that first spacewalk will be this Thursday, October the 5th, starting as scheduled 7:10 a.m. Central Time egress from the Quest airlock. The crew going outside will consist of NASA astronaut Randy Bresnik and Mark Vandehei. This will be Randy's third EVA, and it'll be Mark's first. On the ground, we'll have IV Capcom NASA astronaut Mike Hopkins. And then on board helping out Randy and Mark will be NASA astronaut Joe Acaba and European Space Agency astronaut Paolo Nespoli. They'll be helping Randy and Mark suit up there. Additionally, Paolo will be operating the Canadarm2 during that spacewalk. As Kenny mentioned, the major objective of this first spacewalk is to swap out the degraded latching end effector, or LEA, on the Canadarm2 with an identical unit that's currently located on the mobile transporter. Part of the reasoning behind changing this one out is on August 22nd, 23rd time frame, when we were attempting to walk off the Canadarm2 to the mobile transporter. The latches on that LEA that enable all the power and data to go to the corresponding grapple fixture. Those latches stalled out. They require a little bit more force than normal to extend. So that's why we're changing that out first. The second EVA, or the second spacewalk in the series, will be conducted Tuesday, October 10th. Again, with a 7:10 a.m. Planned egress time from the Quest airlock. We'll have the same NASA astronauts going outside, Randy and Mark. This will be Randy's fourth EVA and then Mark's second. On the ground, we'll have our IVA Capcom will be Kate Rubens, NASA astronaut, and also on board, Joe Acaba and Paulo will help suit up again like they did on the first. And once again, Paulo will be operating the Canadarm2 with Joe assisting Paulo in those operations. The objectives of this second spacewalk include rotating a spare pump flow control subassembly that's located on the external stowage pallet platform 1, and that's to set up for a future ammonia vent of that unit and eventual relocation. We'll also be replacing one of the cameras outside. It's the port lower outboard camera. That's one that we currently have a kind of a pink hue on at this point in time. Again, in helping the LEA that was just changed out on Canadarm2 get back to fully operational function, we will be lubricating the center ball screw of that new latching end effector that was just changed out on the EVA, or spacewalk number 44. Also, we will be replacing a mast camera out on the mobile transporter, replacing a lens cover rather, that we suspect has, the current lens cover has a smudge on there. So we'll be changing that out. And in preparation for a future spacewalk, we'll be removing 2 handrails from the Tranquility module, that's node 3, for future antenna installation. The third spacewalk in the series will be Wednesday, October 18th. Again, planned egress of 7:10 a.m. Central Time from the Quest airlock. This time, the EVA crew will be Randy Bresnik and Joe Acaba. This will be now Randy's 5th spacewalk, and this will be Joe's 3rd. On the ground, we will have IV Capcom NASA astronaut Nicole Mann. On board, Mark and Paulo will be helping Randy and Joe suit up. Once again, Paulo will be manning the Canadarm2, and this time with Mark assisting Paulo. The objectives for this last spacewalk in the series are to replace a redundant failed fuse on the external platform that's located on Dexter, the special purpose dexterous manipulator. We will also be adding a high-def camera to the starboard lower outboard camera group, and replacing the Destiny starboard camera, or the lab starboard camera, that currently has a yellow hue to it. Continuing out lubrication of the newly installed LEA, we will be lubricating the latch ball screws. Those are the ball screws that affect the latch operations. And we will also be removing some thermal blankets on a main bus switching unit that's a spare that will make it usable and compatible with Dexter operations in the future. Those are the main objectives, and so I'm going to hand it over to Tim to let you know a little bit about the arm and the lead, how.
All right, thank you, Judd. So the Canadian Space Agency is really pleased to be here today with our partner NASA to lay out this plan for milestone servicing of the Canadarm2. As Kenny said, it's busy times for robotics on space station, and indeed it seems like every year we're doing more than the year before, whether that's maintenance of the space station, handling and deploying new payloads, catching, releasing, or unloading new free-flying cargo vehicles. Now, since Canadarm2 was launched in 2001, we are more than 16 years into the life of our system. The ARM hardware is divided into components that can be replaced on orbit. So each of the 2 end effectors at each end, each of the 7 ARM joints, or the avionics boxes, or the cameras on the ARM booms, those are all individually replaceable on orbit, either robotically or by spacewalking astronauts. Now, as Judd said, the operation we're going to perform this Thursday will be replacing the end effector at the A end of the arm, the 2 ends A and B, and swapping that with a similar unit on our mobile base system on the mobile transporter. Now, the latching end effector, we call it a LEE. This is the mechanism, a set of mechanisms that does all the heavy lifting, does all the mechanical attachment when the arm walks end over end and establishes a new base point, when it picks up our 2-armed robot Dexter to go do station maintenance, or when it catches or releases free-flying cargo vehicles. The LEE itself is a very complex package. There are a lot of mechanisms, lots of onboard avionics, a camera, a force and moment sensor all in here. It may be one of the most complex electromechanical packages that we've flown in space. The flight unit, it's a little over 1 meter long, weighs a little more than 200 kilograms. And as I said, there is, in addition to the LEEs at both ends of the arm, there's one on Dexter, but also one on the mobile base, which we use as a temporary stowage point for large items, whether they're used in maintenance or whether they're bringing spare parts, as when we replaced a bunch of station batteries back in January. The pallet with all those new batteries was placed on that end effector on the mobile base while all that work was done. Now, as Kenny mentioned, we've been tracking degradation in the Canadarm2 LEEs actually for some years now. Since these components are well beyond their design life, this really is expected wear and tear on the arm, and it's been manifesting itself partly as increased motor currents in the mechanisms on board, and particularly the latches. The system is designed to last a long time, and indeed it's designed to power through obstacles as they come up. So we've seen the latch mechanisms draw more and more motor current. And as we also mentioned here just now, we were going to do a walk-off on August 22nd. We actually had the latches stall during that operation, which is quite unusual. Took a really good look at all the data that we're seeing, and basically that LEE latch mechanism is telling us that it's time. So the plan is this Thursday we're going to swap LEE onto with the end effector on the mobile base, and effectively immediately restoring Canadarm2 to a more operational state, ready to go do more robotics work. Now, after this month's set of EVAs, there'll be at least one more EVA in January. At the end of that time, we'll have moved some hardware around. At that time, LEE will be coming inside the space station for return to the ground, specifically to our prime contractor in Brampton, Ontario, McDonnell Detweiler, and they will set about the refurbishment of that complex unit and preparing it for eventual reflight as a spare. What is now LEE B of the arm will end up as that end effector on the mobile base, stowing large items as they're needed. and we'll be utilizing another spare Lee, which is stored currently out on the space station truss. So that's about it. It's worth noting that we have continued to support station ops all during this period. We were able to successfully release the SpaceX 12 Dragon vehicle on time, and that went perfectly nominally. It did not use that latch mechanism in the end effector, and that went just fine. And we're excited to be here today, working with our partner, working to keep the Canadian robots working in support of Space Station.
Good afternoon. I'm Jacqueline Kagi, and I'm the lead for US EVA 44 to replace the Lee Alpha on the robotic arm. My task team, Farouk Greer, and I kicked off development of this EVA back in July. And then when the issues appeared in August, we switched from the Lee Bravo to a Lee Alpha changeout. With the help of my EMU team, Megan and Goose, and the increment team, Keith, Costa, and Darren, we're well prepared for this Thursday's EVA. The overall flow of our EVA is pretty straightforward, so I'll walk you through it. If we could get the Doug animation going. The crew egresses the airlock, and we plan to carry one bag of tools to the worksite on EV1. EV2 will gather a foot restraint from ESP2 prior to heading to the worksite. Our worksite is near the center of station for the entire EVA. We base our tools on the CETA cart, and then we set up foot restraints on face one of the truss to enable us to reach the arm. The crew ingresses the foot restraints, and the arm flies in between them to allow for the changeout. There are 2 blankets that need to be released to uncover the joint interface. Since the crew cannot reach all 6 EDFs, or the bolts that we need to release at one point in time, we will release 2, rotate the arm, then we will power down and drive the demate connector, and finally release the other 4. The degraded joint will be removed, and the crew will translate it to the CETA cart to a temp stow location. Next, the crew will work on the POA Lee, which is our spare. After power down and demate of the connector, the crew works together to release all 6 EDFs in a star pattern. They release the Lee and translate it to the arm worksite. The crew inspects the interfaces prior to mating, and then they will install 4 bolts to an initial torque. We will power up the arm and rotate it so they can reach the other 2 bolts. Do those to a final torque, and then we will rotate it again to be able to do a final torque on the first 4 bolts. Time permitting, pictures of the bolt final config will be taken prior to putting the MLI blankets back on. Next, the crew will retrieve the degraded Lee from the CETA cart and move it to the POA. They will install all 6 bolts to a final torque, and then finally they will start cleanup from the EVA. They'll gather all their tools and their foot restraints, and they will place the foot restraints in ideal locations for the next EVA. After that, they will return to the airlock for ingress. Thank you. One area for difficulties that we could face are the EDFs, or expandable diameter fasteners. These are the 6 bolts that mate the Lee to the SSRMS or to the POA fixture. As you can see, these bolts are fixed to the Lee, and they attach through the Lee and joint interface with a clevis lug interface. Once inserted, the EDF clicks into an end cap with a hex interface, which enables the bolt to drive. Now if we could bring up the flash animation. As the EVA bolt head is turned by the crew member, the length of the EDF decreases, which forces the collets outward. This will fill the receptacle hole for a friction fit to ensure high stiffness and zero clearance. That is all I have for EVA 44 and the Lee changeout. I'll now pass it on to Glenda, who will talk the other two EVAs.
Thanks, Jackie. I'm Glenda Brown, the EVA officer for the second and third of the EVA triple that we'll be conducting this month. As you know, it takes a village for a lot of the work that we do here at NASA, actually all of the work, but in EVA it's particularly true. In addition to the team members that Jackie mentioned, I've also got a back room full of support engineers, including Chris Mundy, who will be leading the task MIPSR position for the first time, and he'll be backed up by a veteran, Devin Bolch. On the third of the three EVAs, those two guys will switch positions, and Devin will lead it, and Chris will be the backup. We also have Goose again in our back room, as well as Sandy Fletcher for the second EVA, and for the third EVA, we'll have Reagan Cheney supporting at the airlock console. It also takes a huge engineering community. Our engineering team this time is led by Anna Isaac and a host of others. And I want to call out in particular Davey Moore, who has been supporting us for the entire length of the International Space Station. He started as the Vehicle Integration Test Team Officer at Kennedy Space Center on the International Space Station for its very first missions. Davey's going to be retiring this month, and we all wish him the absolute best for the rest of his time. With that, I believe I'm ready to roll the animation for the second of the three EVAs. We'll start the second of the three EVAs at the Quest airlock, as we always do, and Randy Comrade Bresnik will head up to reconfigure a latch on the high-pressure gas tank. Then he'll return, pick up an APFR or foot restraint, and make his way over to the port side of the U.S. laboratory, where he will set up that foot restraint and ingress it in preparation for rotating the pump flow control system spare to its new orientation. Mark will head up to the truss and then move port over to the mobile transporter underneath it to the port CETA cart, where he will stow his tool bag and then grab a foot restraint from the port CETA cart and install it to the robot arm. In order to do that, he'll have to first install a new socket onto the newly repaired latching end effector and then insert his foot restraint. From there, he'll make his way back down to the laboratory to help out Randy with rotation of that PFCS spare into a location where it can be vented. It has an ammonia pad that needs to be vented on a future EVA. Mark will head back to the truss, and Comrade will pick up his foot restraint and head on his way for the rest of his tasks for the day. Mark will separate his tool bags and take the medium ORU bag with him, ingress the robot arm, and Paolo Nespoli will maneuver the robot arm over in front of the camera port number 9 location, which is port, outboard, and lower on the truss. Comrade will bring the large ORU bag with the new camera group out to meet Mark at the work site. Mark and Paolo will first have to work together to remove the high-definition camera from the camera group. That high-def camera was installed about a year ago on a spacewalk, and we're going to be reinstalling it when the change-out is complete. The two spacewalkers will work together to remove the failed camera group from the camera port 9 and change it with the replacement camera group that they've assembled when they were inside the space station. They'll install it to the camera port 9, and then Comrade will pack up the bag with the failed camera and return it to the Quest airlock, while Mark works to reinstall the high-def camera, and then Paolo can maneuver the arm back over to the forward face of the truss, where Mark will egress the arm, change his bag out for the crew lock bag holding all of his lubrication tools. He'll set up a foot restraint and ingress that foot restraint to be able to access the new latching end effector to lubricate the central ball screw. In the meantime, Comrade will return to the airlock and work on a myriad of tasks that we have for him to accomplish. He'll go over to the port CETA cart and then up onto the mobile transporter to replace the camera lens of the mobile transporter camera, and then he'll remove the socket from the degraded latching end effector for use on another EVA. He'll grab the large or the medium ORU bag that Mark was using and return with it down to the front of the external stowage platform number 2, where we keep the foot restraint in support of critical contingency EVAs. He'll return his crew lock bag to the airlock, and then he'll head aft on the International Space Station around the back side to the Tranquility module, where he will work on the end cone of the module to remove 2 handrails in preparation for installation of the external wireless system, the enhanced wireless system on another EVA. Mark will finish his work lubricating the central ball screw and then pack up his bags, return the foot restraint to the port CETA cart from whence it came, and then meet up with Comrade at the Quest airlock for the end of the second of the 3 EVAs. Okay, I brought along a little show and tell. Some of you have seen our grease gun before. This is the tool that Mark will be using to lubricate the robot arm on the second of the 3 EVAs. And then Joe Acaba will be trading places with him on the 3rd EVA and finishing up some additional work on the lubrication. Notice it looks like a caulk gun, a lot like the ones that you've got at home. If you've been doing painting or working with caulking a tile job or something like that, you're using a tool very much like this one. It's got a ratcheting plunger with a handle that pressurizes the grease. It's got a on-off valve that keeps the grease in place, just like when you're caulking at home. If we could roll the video, I've got some video of Thomas Pasquet on EVA 40 when he was lubricating another one of the latching end effectors. You can see the grease gun here in the foreground, and he's working with the other 2 tools as well to lubricate that latching end effector. So if you've done some caulking at home, I guess you're ready to do a spacewalk too. All right, let's roll the video for the 3rd of our triple EVAs. Do we have the video for the 3rd EVA? Here we go. The 2 crew members, Joe Acaba being EV2 and Comrade Bresnik being EV1, will egress the Quest airlock. Joe will head up to face 1 of the truss. This time he's going to be working on the starboard side. Notice the mobile transporter has moved now down to the starboard side of the truss. Randy Bresnik will follow him out to the truss. He'll translate under under Joe Acaba and then under the mobile transporter out to the starboard side of the mobile transporter and up on top where the Dexter robot hand is positioned. He'll be changing out a failed fuse that provides redundant power to payloads as they are moved into position by the Dexter robot hand. Joe will be ingressing the robot arm. Paolo will fly him over to the CP3 or camera port 3 camera location to install a high-def camera. And then Comrade will head back down to the airlock and over to the external stowage platform number 2, where he'll be removing some multi-layer insulation off of the main butt switching unit spare that's in that location. Then he'll grab the large ORU bag containing the replacement camera group for the camera port 13 camera and Joe will maneuver over from the camera port 3 to camera port 13, which is on the starboard side of the U.S. laboratory. The two of them will work together to remove and replace the failed camera group. The replacement unit will also have a high-definition camera already installed on it that they were able to accomplish while they were still inside the space station. Comrade takes that bag back to the airlock while Joe completes the installation of the new camera onto camera port 13. And then Paolo will maneuver him back over to the truss, where he will once again set up his foot restraint for the final lubrication of the arm on this set of EVAs. In the meantime, Comrade goes back to the lower side of the external stowage platform number 2, grabs his ORU bag, and goes onto the top of the stowage platform where the DC switching unit spare, or DCSU spare, is located. He'll perform the same multi-layer installation removal on that spare, making it also compatible with Dexter robot operations. Joe will be working with Paolo to lubricate the latches on the newly replaced latching end effector. Paolo will rotate the various latches into position so that Joe can easily access those for the lubrication of those latch ball screws. He'll complete as much of the work as possible. There may be some additional lubrication required on a later EVA, but we'll try to get as much done as we can before it's time for Joe to return his foot restraint to the port CETA cart and then pick up his bags on the way back to the Quest airlock, where he will meet Comrade for the end of the 3 EVA series. Okay, and that's all we have for the video. I did have one additional piece of hardware that I brought along for show and tell, and it's interesting in that it's probably the oldest piece of hardware that we have on the International Space Station. Here is a copy of that hardware that we use for training here on the ground, and it's the interface that holds the flight support equipment for the pump flow control system spare onto the external stowage platform number 1 on the side of the Destiny lab, or on the side of the laboratory. So this piece of hardware first flew, the very same hardware that's on the station now holding that flight support equipment in place, flew for the first time on STS-80 and on STS-87 when we were testing our various technologies for how we were going to build the space station. It was only really a dream and just in work at that time, and we were trying to figure out how we were going to do it. We knew that we were going to have to hold large boxes in place for both spare stowage and then also to move them around to the work sites. And at that time, we did not have a Dexter robot hand, and we were going to have to be doing that all using mechanical interfaces only. So this is the common structural interface that we developed at that time. This side of it bolts onto the platforms. Think of them as like pallets that you move around cargo on, but they're made of metal, of course. This side bolts onto that, and then the opposite side fits into a square grid like the ones on the CETA cart that we have now, and tangs on each side, we call these latch pawls, hold the whole structure and its cargo in place on the square grid. It's actuated by hand. Remember, we didn't have the Dexter robot arm at that time. And the EVA astronaut pushes in on the button and then rotates the handle to, this is the capture position, where you can push in on each of the pawls so it could go into the square grid but not come back out of it. So in order to remove it, he's got to take it all the way to the unlock position or release position where the pawls are all the way retracted. So that's how you remove it out of the square grid, and then you replace it into the capture position with the pawls out, snap it into place, and then you can take it all the way to the locked position, which really loads up those pawls and puts a preload on the square grid. A very, very simple interface. but it didn't provide any power to the ORUs, and it did not allow for robotically to move them around. So we've upgraded. The first of the spares to go to the International Space Station was the pump flow control system, and it was mounted on one of these. It was prior to the time that we finished what we call FRAM interface. So just a little bit of history for you there. I wanted to pass that on since we're getting to operate this hardware probably for one of the last times it'll be operated. That's all I have. Brandy?
Thanks, Glenda. I love it when we can have show and tell. And actually, along the lines of historical questions, I was wondering if we could maybe start with having Tim talk a little bit about all that the Canadarm has done over the years, and if there's anything that has surprised him and the uses that we've found for it.
Well, as Kenny mentioned, Canadarm2 was a really big player in space station assembly. Most of the large elements on the U.S. segment, most all the trusses, the large modules were handled by Canadarm2 at some point during that assembly. Since then, we have been doing an increasing amount of maintenance. And all through this time as well, we started the age of the free-flying cargo vehicles. The first of those was what we called HTV-1, Japanese cargo vehicle. And that was really a remarkable event to do the first one of those. And since then, of course, the frequency has just been increasing and increasing. And it seems like we do one now every couple months. That really is sort of the quickening pulse of our space station operations. Very often, the Dragon cargo vehicles, which have an external trunk, as we call it, comes full of cargo that needs to be unloaded, and only our two-armed robot Dexter can get in there. So big missions, this next one, I believe SpaceX 13 has 3 in the trunk, and that's going to make for a busy December. And I'm not sure what has really surprised us. I think we're impressed at how much the work is increasing, and the pace of the robotics has just been going up and up and up. It's really exciting to see the system used.
That makes sense. All right, well, we're going to take questions now. We're going to start here in the room. We've got a few reporters here in person with us. We will also take questions on the phone bridge. So if you have a question on the phone, you can use the signal *1. Press that to let us know you have a question. If your question gets answered, you can press *2 to dismiss your question. And just a reminder that we'll also be taking questions from social media. You can turn those in using the hashtag #AskNASA. Let's start over here.
Thank you, Mark Carew, for Aviation Week. I believe this is for Kenny. The Canadian arm in its current condition, could you capture the cargo module that you're planning to launch in November for orbital ATK?
We would have, there is some power that's required for that module. In order to apply power to the module once you capture it, you have to extend the latches. So we need to try to get this fixed before we fly orbital. So at this point, that's one reason we're angling to go get it now during this triple EVA, is that so we can make sure we're good to go for OA8.
Thank you. And this is a question for clarification, and I feel sort of bad about asking it because the explanation was so thorough, but the lead that you're changing, is it the one that's extended normally or the one that is attached normally to the station?
It's when we do operations, both ends are the same, and so you know, that's one reason we continue to take a look at them, take a look at the snares, take a look at the how they're performing, because of the fact that we use them interchangeably. We don't really try to sway this way or that way when it comes to base or the one that's doing the actual capture. So we don't discriminate.
No matter where A was in the rendezvous, cargo rendezvous operations in November, it still needs this repair. Yeah,
and it has to latch on the base side because that's where the power is going to come from, right? And then if you need to extend that all the way out to the orbital ATK Cygnus module, you'll need to extend the latches there as well to ensure that you can get power through to the module.
Hi, Robert Perlman with Collect Space. Just to first clarify, how many total spares of the Lees are there? I think there were mentioned 2, but are there more on the ground?
So the end effector on the mobile base, we're going to use as a spare this time. So it's there. There is another spare that was launched on a cargo pallet that's out on the truss right now, and we have another what we call our launch on need spare Lee on the ground, ready to launch. So you could say there are 3 spare Lees in play, but after this Thursday, it'll be only 2.
And I believe you mentioned that the Canadarm was, that this was somewhat expected given the lifespan of the arm. What was the projected lifespan in total for the arm? And is this the first major R&R that you're doing on the arm itself?
So the arm was designed to last for the whole duration of the space station program with maintenance. So all of these components, the end effector is designed to be replaceable, as are all the joints. The life of the components, I spent some time looking back at our design documentation. We used a 10-year figure during the course of that. For some aspects of the design, we also used 15 years. Here at 16 years at counting, honestly, for an item this complex, we're actually very pleased that both Lees lasted this long. We thought we probably would have been doing this maintenance before now. But the fact that they lasted this long is a really great thing. As far as other maintenance, we actually did a joint replacement in June of 2002. That was obviously early on, within the first year of the arm being in space. And we detected a short in what was then the wrist roll joint. That was before the mobile base showed up. The arm was on the lab, and that was the only base. And the wrist roll joint needed to be replaced. We did that on STS-111 in June of 2002, and that went incredibly well. And actually, that was a great demonstration that you can do just this task, because in order to do that, we had to take the end effector off to get to the joint, and that went really, really well. So we've got a great precedent for this Thursday is going to go just fine.
All right, we'll take a question from the phone now. I think we have one waiting for us from Mark Gotch. Are you online, Mark?
Well, Mark Gotch, Historical Aerospace News Media. Thank you, ladies and gentlemen, for such an informative briefing this afternoon. A question, first off, will the latching effectors being replaced, will there be differences to them and any other mechanisms in the future to accommodate future missions that will be bringing astronauts from Cape Canaveral at the Kennedy Space Center to ISS? Will there be any changes to accommodate spacecraft like the Boeing Starliner and the SpaceX Dragon capsule coming to the ISS?
Well, let's see. So it's a good question. From the standpoint of the arm, there's no design changes that are being made to support the new crewed vehicles that will be coming to the space station. And in fact, some of those are going to be docking, so we wouldn't really have an arm interface relative to getting them on station. But no, there's no plans to update the arms or the latches or any other parts of the manipulator system. It's good to go.
Thank you.
Along the same lines, we have a question from Colby on Twitter, who wants to know what kind of technology we can look forward to in future spacewalks, and maybe not just on the space station, but in Orion spacewalks in the future.
Well, I think I'll take a cut at it, and I'll let you guys have it. But anyway, spacewalks are something that if you look at through the history of human spaceflight, at how far we've come and how much we've learned an incredible amount just in the last 3 or 4 years about how to take care of spacesuits on orbit. You put behind that all the work that's been done here on the ground to update suits and upgrade suits from back even in the Apollo days and prior. So it's a continually evolving sort of art, this whole spacewalking thing. So anyway, I anticipate that as we go forward and we get into other missions. We'll have to look at the requirements at that particular time, and we'll take the best technology that we have that we can prove out in the environment that we need to prove it in, and we'll be ready to go. So again, I think we were learning a lot with space station about how to care for suits in orbit, and that's going to benefit us going forward in terms of when we get further from the planet. And we need to do a spacewalk. We need to know that we know how to take care of the suits, and we need to make them as flexible as we can in terms of how we take care of them, so that they're there for us when we need it. So anyway, again, it's continually evolving, and it really is just, we're only limited by whatever technology can give us, and every day that's changing. So we're always looking to learn and upgrade when we can.
For Glenda and Jacqueline, anything on your wish list for future technology?
One thing on our wish list is the current suits. They were designed for ground launch and use for a couple weeks and then return to orbit before refurbishing them. So future suits will need to be more of an ORU type, where you can change out pieces as they fail, so that you're not trashing a whole suit, where you can bring up new pieces or build new pieces while on orbit and have redundant systems.
That's all for the spacesuit side of it. I'm all excited about having new spacesuits as well, but some of the new technology that we're deploying on these spacewalks and on the next few, as I mentioned, we're installing those new high-definition cameras. We'll have those positioned then all across the space station, so that's going to give you guys some great views. Earth ops views are just amazing, so we're really excited about bringing you that. The external wireless system is newer technology to transmit those signals around the space station. They'll also be working with the new high-def cameras to give us a much better technology there. And then we've already installed one of the new docking systems for the new crew vehicles that are coming, and next year we'll be installing the second of those two docking ports. So those just a few of the new technologies that we're bringing on board now, and continue to upgrade the space station as we go.
Lots to look forward to. We have a few good kind of Spacewalk 101 questions coming in on social media, so we're going to cover a couple of those, and I think that'll be just about all we have time for. But first of all, Duke on Facebook wants to know, how is a spacewalk possible when the space station is traveling 17,500 miles per hour?
Okay, I'll take that one. That's an excellent question, Duke. So let me describe it to you this way. If you were on your car, on the outside, say you were standing on top of your car, and your car was moving along at 20 miles an hour. You're moving along at 20 miles an hour too. But you're not falling off because you're going the same speed. If you got moving fast enough, you probably would. But in this case, we're just moving at the same speed relative to the space station. Or think of yourself standing on the Earth. We're standing here, the Earth is spinning around really fast, but we're not flying off. It's because we're right here moving at the same speed as the Earth. So for the astronauts, it's like they're not moving at all relative to the space station. Does that help?
Makes sense to me. And one more kind of along, not quite the same lines, but just for somebody who maybe hasn't been following along with NASA for too long, want to know what we would do if an astronaut was injured during the spacewalk. That's from Elizabeth on Twitter.
We have a bunch of contingency procedures, and the crew has them in their cuff checklist. It's a list of procedures that they can reference to anytime during the EVA. And we try to think of any issues that may happen, whether it's medical or suit-related issues, and give the crews what they should follow through to return to the airlock and get themselves safe inside the airlock before we can repress and bring them back up to any medical services back when they're back inside. So we do practice those with the crew and plan for any scenario that we can think of.
Hopefully we won't need those coming up, but we are getting ready for the spacewalks that are coming up, and we're going to sign off now, but remind you to tune back in starting this Thursday on October 5th, and then following that on October 10th and 18th. Our NASA TV coverage will start each day at 5:30 a.m. Central Time, and then we'll expect to see the crew go out the door probably a little after 7 a.m. Central. You can keep up with all of the space station news between now and then at www.nasa.gov/station, and we'll see you back then. Thank you.